Today we're talking about congruent chords and arcs. So we look at the diagram, a bunch of lines, but if I know anything about two similar pieces in that diagram, then I know lots of other things about that picture. So let's start with the basics. Two chords are congruent. If and only if, that means these conditions must be met, their corresponding arcs are congruent. So that means that arc AB has to be congruent to C. Wait a minute. I'm talking about segments. So chord AB is congruent to chord CD. If and only if, that's what this is, or IFF, if and only if, the measure of arc AB is congruent to the measure of arc, not angle, arc CD. So it goes both directions. The chords are congruent if the arcs are congruent, and the arcs are congruent if the chords are congruent. The second criteria is they are equidistant from the center. That means that chord AB is congruent to chord CD if and only if FE is congruent to GE. If a diameter or radius is perpendicular to a chord, so if you look at EI, that's a radius, and it's perpendicular to the chord CI, then it bisects the chord and its arc. That means that since this is perpendicular here, that these pieces are congruent and these pieces are congruent, because bisects means cut into two equal pieces. So in short terms, that means that since EG is perpendicular to AB, that means that AF is congruent to FB, and the measure of arc AH is congruent to the measure of arc HB. So just by looking at the pictures, as soon as I see those two perpendicular angles or perpendicular intersections, I know that these have to be the same, and these have to be the same, and these, like everything about that becomes congruent. So let's go look at the first example. Given this diagram, I tell you that the chords are congruent. Right here, it says, okay, SR and ST are two chords and they are congruent. The first definition says that if they're congruent, so are their arcs. So that means that I can say that 7x plus 24 has to equal 115. So we subtract 24 from both sides. 7x equals 91. X is 13. That's it. Just because I know that those two arcs are congruent, that's given to me. And since I know that the two arcs are congruent, the two the two chords are congruent, so the two arcs have to be congruent. So that's how we can move through this. So let's look at the next one. This time I tell you that the arcs are congruent, but I told you that this sentence goes both directions. This time the arcs are congruent, that means that the chords have to be too. So that means that 18x minus 2 has to equal 52. So we're going to add 2 to both sides, so that 18x equals 54, x is 3. Just because I understand what those symbols mean on the diagram, and then I remember the property that lets me say that. Now, what's different about number 3? Again, I give you two chords that are congruent. That means they're arcs, they're corresponding. And by corresponding, I mean this is arc WV and this is chord WV. So the same two endpoints. That's what it means by corresponding. So if we know that the arcs are congruent, then the chords have to be congruent. And I can just set up my equation to 9x minus 34 equals 4x plus 1. So I'm going to subtract 4x from both sides and add 34 to both sides so that I get 5x equals 35, x is 7. But I ask you to find xy. So xy is 4x plus 1. That's 4 times 7 plus 1, so that's 29. So again, it's just understanding what the diagram means and what to do with those pieces. This time, I tell you that the chords are congruent, so that we know that means that the arcs have to be congruent. So I can say 11x minus 72 equals 5x plus 6. So I'm going to subtract 5x from both sides, and I'm going to add 72 to both sides so that I get 6x equals 78. So x is 13. But that's not what I ask. I need the measure of the arc. So the measure of arc RS equals 11x minus 72. So that's 11 times 13 minus 72, which is 71 degrees. So as soon as you understand what the symbols mean, then it's just an algebra problem. So now let's look at number 5. Now this one's not harder, you just have to apply what we've talked about. So I told you that these two chords were congruent. That means that these two arcs have to be congruent. So what does congruent mean? Congruent means the same. And in this case, the same is an algebraic expression. So this is 6x minus 20. Now I have some kind of value for all three arcs, which need to total 360 degrees. So I can say 6x minus 20 plus 76 plus 6x minus 20 has to equal 360. 1, 2, 3 arcs. So let me combine like terms. 6x and 6x is 12x. Minus 20 plus 76 and minus 20 is minus 40. No. think I did that wrong in my notes. $76 minus 20 minus 20, yeah, equals 36, equals 360. So we're going to subtract 360 from both sides, 36 from both sides. So that I get 12x equals 324. We divide that by 12, and I get x is 27. So that wasn't bad. All I'm looking for is x. Now the next one starts taking us into that next diagram where we got a couple more pieces. So this time we're looking at the second property that says the second property says that if the radius or diameter is perpendicular to a chord, then it bisects everything. So I know that these two chords are congruent, which means, my arcs are congruent, which means my chords are congruent. And I know that that means that these are bisected, which means all four of those pieces are now the same. And just in case I needed to know, these four pieces of arcs are also all the same. And because the chords are congruent, that means they have to be equal distance, so technically those two little pieces in the center. So just from that diagram and one thing but being marked congruent, I know that everything else is. So now let's look at what we've got. Because I knew that these were congruent, these have to be equal distance, and equal means that they are the same. So here's MP and here's PN. Those two things have to be the same. So I'm going to say that 5x minus 34 equals 2x minus 4. Subtract 2x from both sides, add 34 to both sides. I get 3x equals 30, and x is 10. But that's not what I asked you for. I asked for MP. So MP is 5x minus 34. That's 5 times 10 minus 34, which is 16. So all because I told you that one set of chords was congruent, and their corresponding arcs are congruent, and they're perpendicular, and they're equal distance, and they're bisected. Like, all of that comes just like a row of dominoes. All right, let's look at number 7. So this time, what you're given is the idea that the two chords are equal distance apart, and they're perpendicular. So now, based on this diagram, these four pieces are the same. Probably should use a different mark. And then I can figure out how much DE is. So because it bisects it and they're equal distance, that means that 11x plus 15 equals 32x minus 27. So we subtract 32x, because I like to move my variables left. We subtract 15. I get 21x, negative 21x equals negative 42. X is 2. But I ask you to find DE. So DE equals 11x plus 15. 11 times 2 plus 15. 22 plus 15 is 37. Again, it comes down to looking at the diagram and matching it to one of the properties that you're given, and understanding what the notations mean. So now we're going to look at number 8. This one tells me, again, that these two small lines are congruent. That means that MN and PN are equal distance from the center because they're at right angles. Because they're equal distance, they have to be the same. So that means that this line and this line are congruent. And we know that if the chords are congruent, the arcs are congruent. So then what we're going to do is say that 9x minus 43 equals 5x plus 33. So then we'll subtract 5x from both sides and add 43 to both sides. 4x equals 76. X is 19. But I ask you for MP. Now, first of all, notice where MP is. It's not one of the ones that you were given expressions for. So then what I got to do is figure out MN. So the measure of MN is 9x minus 43. That's 9 times 19 minus 43, which is 128. Okay, so this is 128, and so is this. So what's that piece? Well, the measure of arc MP, on a straight line, equals 360 minus 128 minus 128, which is 104 degrees. All right, let's look at number 9. Number 9 is easier. It doesn't look like it is, but it's easier because there's no algebra. You're just identifying the pieces. So let's start with the fact that RS, so the whole thing is 18. Because these pieces are congruent and they're at right angles, that means that I can go through and say, well, then this piece is congruent to this piece and that piece is congruent to that piece. And oh, while we're at it, these are congruent and these are congruent. So now that I've done that, now it's just about using the numbers that I have. So TY is this little piece over here. And so every place that I have 2 blue tick marks, I'm going to put 42. Now, RS is 18. That means that each of its pieces, so RW and WS, each of those have to be 9. We know it bisects. Where there's a 1 green line, those are all 9. That's all I need. Now I'm either going to write that number down or I'm going to put it together. So TV is this piece right here. We already said that that's 9. And TU, well, I know that those are congruent, so that's 18. And WS, that's also 9. And then arc YU, that's 42. And RS, well, that's just 42 plus 42, so that's 84 degrees. That's it. Again, once you understand the symbols, I just know that all those things are congruent. So now let's look at circle I for number 10. So BG's right here. This is 17. That means this is 17, this is 17, and this is 17. And this big arc is 256. Well, that means that this arc is equal to this arc. So BC is congruent to BA. And I find that by saying 360 minus 256 and dividing by 2. And that gives me that each piece is 52 degrees. So this is 52 degrees and this is 52 degrees, which means that each little piece is 26. That's it. Now I just got to figure out what I need. So segment BC is 17. Oops. Segment FB is also 17. Sorry, is that BC? It is BC, not BG. BC is all the way across. That's 17 plus 17, that's 34. Arc AB, that's the whole thing, so that's 52. Arc BC, same thing, 52. And then arc EC, that was half, so that's 26. So just from knowing that these two pieces are congruent and perpendicular, everything else falls from that. Now let's look at number 11. So we're talking about QM and MR. So again, because these are equal distance and perpendicular, all these pieces are the same. So that means that QM equals MR. So we're going to say that 6x minus 11 equals 2x plus 9. Subtract 2x from both sides, add 11 to both sides. 4x equals 20, x is 5. But what I asked you for was MR. So what I want is this piece. MR equals 2x plus 9, 2 times 5 plus 9, which is 19. Actually, I read that wrong. What I want is the whole thing. But if this is 19, then MN equals 2 times 19, which is 38. So pay attention, don't make the same mistakes I did, read the question correctly, because this part, once you figure it out, it's pretty straightforward. The trick will be in answering the question that you think you're looking for and the answer that I was actually looking for. Let's look at number 12. So this time we're talking about arcs. It doesn't matter, the same thing applies. CI and EF. So what does that mean? Well, CI is half and EF is the whole thing. That just means that 2 times 7x minus 15 equals 12x minus 8, right? Because this is 7x minus 15 and this is 7x minus 15 because I know they're the same. And this whole thing is 12x minus 8 and those two pieces are equal, so we just write it like that. So I have 14x minus 30 equals 12x minus 8. Subtract 12x from both sides, add 30 to both sides. 2x equals 22, x is 11. Now this time we'll be careful. I'm looking for CI, so I'm just looking for that. So the measure of arc CI, which is 7x minus 15, 7 times 11 minus 15, that's 62 degrees. All right, one more thing about chords. So this time the diagram is only one chord. It doesn't change a lot of the properties though. So what we're trying to do is figure out, to start with, WV. So because my radius intersects my chord at a right angle, so because that's the case, what that tells me is that these two pieces are congruent. Now I don't need to know that yet, but I need to know it for my first question. So how am I going to find this blue part of the circle so that I can double it? That happens to be the leg of a right triangle. So I can say that 5 squared, I'm going to call this x, plus x squared equals 13 squared. 25 plus x squared equals 169. X squared equals 144. X is 12. Okay, great. This is 12. So VW is 2 times 12, which is 24. Every time you see a right triangle, you should think Pythagorean theorem, and then you should think SOHCAHTOA. Every time. So now, what I'm asking you to find is this arc. Well, I want you to see that this is a central angle. We learned about central angles, and central angles equal their arc. So the first thing is that angle YXW equals the measure of arc YW. That's the first thing. So how can I find that angle? That angle for this, that's this angle right here. This angle, this is opposite, hypotenuse, and adjacent. So I can say that the sine of theta, because I'm going to call this theta, is 12 over 13. That means that theta is the inverse sine of 12 over 13, which is 67.4 degrees. So the angle, which equals the arc. Now you won't have that on your tests the first time, but every time you see a right triangle, the first thing you should think is, can I use the Pythagorean theorem, and can I use SOHCAHTOA? So now let's look at number 15. So we have a different diagram. This is just twice as much stuff. So the first thing we want to notice is that HK, that's this whole length, is 30, which means that each of these pieces is 15. And then it says that PM is 8, but that means that PN is 8 as well. So if this is a right angle, then this is a right angle. What I'm looking for is PH. That's the hypotenuse of that right triangle. So I can find that by saying 8 squared plus 15 squared equals, we'll call this y squared. 64 plus 225 equals y squared. That's 289. So y is 17. And y is also pH. Okay, so that was just the right triangle using the Pythagorean theorem. The next thing that I want to find is I want to find the measure of arc GJ. Well, the first thing I'm going to do is figure out how to find this angle. Because once I have this angle, it equals this, and I know that this and this are congruent because of these symbols. So once I have this angle, I can just double it, and that will be my big arc. So to find this, again, it's a right triangle, that's SOHCAHTOA. I'm going to call that theta. I'm going to say that the tangent of theta equals 15 over 8. So theta equals the inverse tangent of 15 over 8, which is 61.9 degrees. So then that's this side, and this side is also 61.9. So the whole thing, the measure of arc JG, is 123.9. 8.8. So it's all about looking at the pictures, understanding which pieces you know to be congruent based on the given information, and then using algebra, sometimes some trig, Pythagorean theorem, to solve for the missing pieces.